Yeah, so the one way would be obviously the algebraic way, right?
What do you mean by the algebraic way, though? Because technically there is the algebraic way and the calculus way.
So which way do you do it?
I like the calculus way, but that's I love calculus.
But then again, that's
you're
two
gonna
different.
have to walk me through that.
Yeah. Then again, that's two different ways of doing it, though. By doing it through calculus and one through algebra.
I think it'd be neat if we could find something that's not as hefty in math, if you will, though.
Yeah. You could almost do a table.
I like a trial and error kind of way.
Yeah.
As well, like something that.
I like the idea of a table, because you can like start off like if x
We
is
just
1,
sort of- right.
what would
Yeah.
100 minus 2x be?
So like x. 100 minus 2x.
And then find the perimeter and the area as like
Yeah.
columns on it. I could do that.
Lots of problems.
I could do that on an Excel sheet.
Ooh, getting fancy. So we could do the table, and then you want to do the
I think that.
Calculus way?
calculus way.
Is everyone okay with that?
Can I throw in the algebra way? Is that?
How do you?
Can I do that as well?
Yeah, we could do it 3 ways.
Because it's going to be a parabola.
I was thinking, in order to maximize the group work instead of like going off to our tasks, we should probably like take each other through.
Yeah.
You want to start?
So, here, why don't I
Maybe go up.
Always the
show you the calculus way, if you will?
Yeah.
Yeah.
And then we can look at the algebraic and then yours, and then we can decide 2 that we want.
Yep.
All right.
In so many different classes.
So for calculus, it's a maximization problem. So basically, the idea is that you're trying to figure out the largest possible area. So you want to write your area function, area equals length times width, where your length is x and your width is 100 minus 2x. And you want to distribute the x to make it a simpler equation. And then you want to take the derivative.
Okay. It's been a while.
So a prime equals 100 minus 4x.
I did that right.
And then you want to...
So you divide it by x?
You don't divide it by x. What you do is you take the exponent, bring it down and multiply it by your coefficient, and then subtract 1 from the exponent of your variable. So here it's a 1, you bring it down, multiply 1 times 100 is 100, and 1 minus 1 is 0. So x to the 0 is 1 disappears. And then 2 times 2 is 4, and then 2 minus 1 is just x to the first. And the derivative represents the slope of the tangent line to your equation at any point. So you want to look, a maximum always has a slope of 0 because it's a peak.
Okay, yes.
Because it's increasing and then suddenly it switches to decreasing.
So you set it equal to 0.
Exactly. And solve for x.
We start out with the same idea of the equation of the area. Is the length times the width, and then we get that same 100x minus 2x squared, which we know is a parabola. And then it's a parabola facing down because it's the negative 2 in front of the x squared. So the maximum area would be the peak of the parabola, which happens at the vertex. So the equation for the equation for the x value is minus b over 2a. So in this case, our b is the 100, and our a is the negative 2. So we would have negative 100 over negative 4, which just gives us our 25, which would be the x.
To me, I think the calculus way makes more sense. Or it's easier to explain in writing.
Yeah.
It's the algebra way makes sense, but you have to have a lot of knowledge about algebra, and we'd have to sit and explain. We know that this is an upside down parabola because of the negative slope, So, whereas with the other one, we're just like, this is a maximization problem. This is how you solve it. And then I say for the table, I was thinking about this. Instead of starting at like one, like going 1, 2, 3, 4, 5, maybe go 5, 10, 15, 20, 25.
Yeah.
And then like, cause like you could start like that if you were doing this in a class, and then be like, oh, well, it falls between 20 and 25
Right.
if it wasn't like exactly.
Right.
And
Yeah.
then
And
do
that would be
those.
good to like combat, you know,
Yeah.
weariness. Because like I know like for my kids, if it was like, even if it's just something like 100 minus 2x, like that takes time, and they
Yeah.
will make mistakes somewhere in there, and yeah.
Yeah. So just like encourage them to go by steps.
So it equals, so I just set up a column for, there's x, there's 100 minus 2x, and I just said, so it equals 100 minus 2 times, and then whatever the contents of that cell were. And then area, the formula is just this times this.
Great.
Perfect.
So you can just extend those right
Exactly.
down. And
Oh. Oh,
So
right,
you
you have to
filled
extend
it
the
in.
first one first.
I would say almost go to 30 because
Yeah.
then you can say, oh, well,
Yeah.
we
Well-
can't have 30.
They said, what should the dimensions of the new garden be if it is to have the largest possible area? So the question doesn't even ask us for it.
Yeah, but then it tells. Then wouldn't it be 25 would be our x?
Mhm.
So
it'd be
that would be our
25
length. So it'd
by
be 25
50.
by 100 minus 2x.
Yeah, exactly.
Yeah, okay. I thought when you said to plug it in, you were saying to
Oh.
plug it into the original equation. I was like,
I'm sorry, I meant to plug it into
Yeah.
100 by minus 2x. So it is a
25 by 50.